Good afternoon, everyone. It's me again, Hector Nkosi. I'll be taking you for mathematics, guys. I hope you're well. Um, Today we are doing the last part of our analytical geometry. We're just looking at the last question so that next week we can start with the next chapter. Remember, guys, if you've got any question, don't forget to email me at nkosihector28@gmail.com. Right, guys, I just need to check the participants, the usual people that are here. I can see you guys. Hello, everyone. Uh, Arlie, Bed, EDP 445, Joe, Kabza the Small, Kamugelo, Letabo, Luna, Nelly, Poppy, Sophie, Sean, Tabiso, Tino, Miss P. Okay, guys, afternoon, everyone. Afternoon. It's good to see you again, guys, and I hope you can hear me. I hope you can hear me from your side. That's perfect. Yes, I can see the comments. Okay, cool. That's perfect, boys and girls. All right, guys, let's start with our today's lesson. It's going to be a short one, 40 minutes again, because I did not want to pile up. I don't want to pile up the work, guys. So it's good to keep it 40 minutes. If we exceed, we're going to do 45 minutes. But yeah, it's good like that because now if I do lots of things with you, you end up being confused and I'll have to go back again the day after. But if I keep it to 40 minutes, then the grace period or grace time of 5 minutes, it's going to help us to what you call to, if you've got any questions or to furthermore elaborate on what I've been explaining, boys and girls. Okay, today we'll be looking at November 2015, paper 2, right? Okay, before I do that, I need to show my details. Remember, you can always email me here, guys. This is our last day. Please, guys, feel free to ask any question. Today we are closing analytical geometry. By today, you need to be comfortable with analytical geometry. Next week, we are starting a new chapter. We'll be starting number patterns, right? So make sure that you are comfortable with analytical geometry. You are fine. Any questions, any things that you are uncertain about, any things that you're still not sure about them, they are still confusing you in terms of the content, in terms of the formulas and stuff. I'm here to help. As for next week, we are doing the new chapter. Okay, I just need to stop sharing and reshare the new document as usual. Okay, I need to share the document. Okay, share. Okay, this is November 2015 paper 2, the Department of Basic Education paper. Question 3, I mean to say, right? We're looking at the analytical geometry. Remember, guys, can you see how I'm doing things? I try by all means to do different questions, and I try also to show you how do they ask questions in a different way. So, you know, after today, you would know what are common questions that they like to ask in analytical geometry, things that you need to look for, things that you need to put an eye for, and stuff like that. Okay, I see some chats. Okay. No. We're doing patterns on Monday, Miss P. Today we are finishing the last topic on analytical geometry because I got some few other emails saying that some other people they still don't understand what does it mean by parallel lines and stuff like that. So I just thought of saying of redoing another question so that you guys can be fine with everything. But after today, we should be done with analytical geometry. On Monday, next week, we're starting number patterns. Okay, cool. All right, that's perfect. Cool. So now here it says to you in the diagram, C is the point on Y axis. So we see this is C, right? Is the point on Y axis, right? And it says such that A is 0 is to 4. This is point A. They've given us point B. It's -4. I mean, it's 4 is to -4. Here's -4. I mean, 4 is to -4. And D, it's -4 is to 2. That's point 2, right? Our vertices of the parallelogram A, B, C, D. Remember, guys, we have dealt with a triangle, we have dealt with a kite, we have dealt with a rectangle. Now we're doing a parallelogram, guys, right? So can you see they're asking different shapes? So you need to be familiar with all your shapes, guys. I cannot emphasize that. You need to know the properties of all the shapes, especially the 2D shapes that you have dealt with them in grade 9 and grade uh, especially in grade 9. I know you have dealt with 2D shapes. Even in grade 8, some of you did them in grade 8, then finished them in grade 9, you know. So you need to know that, okay, a parallelogram, what are the properties of the parallelogram? Already here, the examiner told you, because it tells you that this side is similar to that, and this one is similar to that because of the arrows, right? Here there are two arrows, here there's one arrow, meaning that this is similar to that, and this is similar to that. And also the height in between from here to there, it's similar to that. As you see, there's one arrow here. Does it make sense? So guys, you need to be comfortable with everything, guys. Please, 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 if you want to master your analytical geometry, you need to be familiar with your shapes and any other 2D shapes. You know, it can be, except for a circle, because I know a circle, it has its own chapter in grade 12 where you'll be dealing with circle geometry. But other than that, other shapes, whether it's a triangle, whether it's a parallelogram, whether it's a rhombus, whether it's a square, you name them, guys, whether it's a kite, whether it's a trapezium. So you just need to know all the shapes, know their how to calculate their area, know how to calculate their perimeters and stuff like that. That one, guys, I cannot emphasize. You have to know those things, right? Then it says here, K is the point, not is to negative quarter. I mean, 2 quarter, right? So this is point K, right? So now here's not, it's this one. Yeah, it's this one, point K. And L is the point on A, B, such as that KL, where is KL? KL is, remember, 2 lines, guys. Sometimes they won't tell you the name, but they will tell you the sign. You also need to know the sign. So these 2 lines means parallel. So KL is parallel to CB, meaning now, what do we know about parallel lines? What do we know about parallel lines? We spoke about them yesterday, guys. We spoke about them yesterday, guys. Parallel lines. Anyone, guys? They never meet. Yes, that's good, Palisa. Yes, right. Okay, I just need to read the comments here. Okay. Yes, Juju, this is part of Terms One's work. Okay. Welcome, Juju. It's also my first time meeting you today. I'm used to other people, but welcome to our learning platform. Yes, Palisa, same distance apart. Yes, Tino, very good. They're the same distance apart, but they never met, right? Tracy, yeah, pretty much not that hard. Perfect. That's perfect, guys. Okay, cool. You guys are so amazing. You know, I wish you were my students. I wish you were my day-to-day students, you know. Even my students are very good, but I just wish you were my students because I love your behavior. It's good to work with you guys. Yeah. Okay, cool. Cool. Then it says calculate the length of diagonal DB, right? So this is D and that is B. So remember, if the question says calculate the length, remember now, length, you have to do what, guys? The length, you have to calculate what? You have to calculate the distance, isn't it, guys? You need to use what? Your distance formula. Does it make sense? Every time you are calculating your length, you're calculating the distance formula. Don't forget that, guys. Right. Okay. So now, since we know that this is the length, we have to calculate distance formula. This is how they did it here. So dB, so it's point D and point B, right? So you put your distance formula here. So that's your formula. It's x1 minus x2 all squared plus y1 minus y2 all squared, right? You substitute your x's here for both D and B, y is here for both D and B. Then you'll get 64 plus 36, that's 100, square root of 100, it's 10, right? So the distance between D and B, the length is 10, right? So it's 10. So basically your answer is 10. Let me see some comments before I move to another question. Okay, cool. Okay. All right. Okay, cool. That's perfect. Oh no, that's nice, Monica. She's saying we wish you were our teacher. I'm glad I'm making an impact in your lives, guys. That's perfect, guys. That's perfect, Sarah, Tracy. That's perfect. Okay, cool. Okay, let's move to the second question. Now, it says calculate the coordinates of M, the midpoint of DB. Basically, now you need to calculate what? The coordinates of M, guys. So M is somewhere here, right? Because this is DB. So M is lying somewhere here, the midpoint of DB. You should know the formula of a midpoint by now, guys. Um, the formula of the midpoint, we know it's always midpoint x1 plus x2 over 2 is 2, y1 plus y2 over 2. Then you're saying, okay, the x's of D and the x's of x, right, over 2, the y of B and the y of D over 2. Then your midpoint of which is point M, it's 0 is to -1. Easy marks, boys and girls. Very, 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 very easy. Does it make sense? Okay, that's perfect. Let's look at the second question, gradient of AD. So AD. Before we do the gradient, let me check the comments on the chat box. Okay, cool. Let me see, everyone is following. Okay. Yep. Never stop talking. Okay, cool. Okay, that's perfect. That's perfect, guys. Okay, now gradient. Remember, guys, who can tell me? I said to you, okay, the question says calculate the gradient of AD. Here's the gradient. What kind of slope is this? Is it a downward slope or is it an upward sloping? And what do we know about the gradient of a downward sloping and the gradient of an upward sloping, guys? I want to hear the answer. Yes, it's an upward sloping. And what do we know about the gradient of the upward sloping? Yes, I can see the answers, guys. You guys are so perfectly. Tabo says upwards, Miss P upwards. Yes, but What do we know about the gradient of an upward slope? What do we know about it? Positive. Very good, Sarah. Very, very, very good, right? It's positive, right? It's always positive, right? But for downward sloping one, it's always negative. Wow, you guys are so awesome. You guys are so brilliant. It shows that you are following, okay, let's calculate our gradient, right? So the gradient formula is given by y1 over y2, minus y2 over x1 minus x2. Then all your y's as a numerator, all your x's as your denominator. So it's the y for A and D and is the x for A and D. Then you'll get 4 minus 2, it's 2, then 0. Minus 4, it's 4 because we know minus and a minus, it's a plus. So the gradient, yes, guys, it's what? It's positive. No wonder we got what? We got half, positive half, because it's an upward sloping. Can you see, guys? The more you do questions, is the more you're going to be familiar with your work, guys. These things are so simple, but only if you do lots and lots of your questions. You can't do one question and expect that everything will be fine, guys. You need to do lots and lots of questions, difficult questions, and see how they ask questions in an exam or test or assessment, Perfect. Now, let's move to the next question now. It says to you, the next question, prove that AD is perpendicular to AB. So now, prove that AD is perpendicular to what? To AB. Is perpendicular to AB. What does it mean? We know that what does it mean when we talk about perpendicular lines, guys? This is the recap, guys. Please tell me the answer. Yes, Tracy, 90 degrees, right? And how do we prove whether two sides are perpendicular? What do we use? And what answer must we get? I'm listening. I'm listening from the chat box. Yes, Tino, you're right. Perpendicular means 90 degrees. But how do we prove whether AD and AB are perpendicular to one another? What answer must we get? What must we take in order to see whether that these things are perpendicular to each other? We did it yesterday, guys. We did it. I just want to see whether you guys are following, guys. Not exactly. Not exactly. You don't use your properties, but what do you use, guys? We did it yesterday. Going once, going twice, going thrice. No, 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 no. Not characteristics, guys. Perpendicular lines, meaning that your lines are meeting at 90 degrees, right? And if your lines are meeting at 90 degrees, meaning that when you multiply the two lines, they must give you -1, guys. That's what it means when you see that your lines are perpendicular to one another or to each other. Remember, we did a very same question yesterday about perpendicular lines. So basically, when you take the gradient of AD and the gradient of AB, when you multiply those two gradients, they must give you -1. Therefore, that's where you will see that AD is perpendicular to AB. Does it make sense, boys and girls? We did it yesterday. Maybe you forgot, but can you see the importance of recapping and doing lots and lots of questions so that you don't fall behind, you understand majority of your work, right? So now, if you look at the working, we don't have to calculate the gradient of AD because 3.3, we have already calculated our gradient for AD and we got it as half, right? So the only gradient that you have to calculate is the gradient of AB, right? By now you know how to calculate the gradient. So the gradient of AB will be y1 minus y2 over x1 over minus x2. So it's y over changing x. So this is y of A and y of B over x of A and x of B, right? And the gradient of AB, we got it as -2. Does it make sense? We got it as -2, right? Therefore, you need to take the gradient of AD, of which is half, and multiply it by the gradient of AB, of which is -2. And you'll get what? You'll get -1. Therefore, AD is perpendicular to AB. That's how you prove perpendicular lines, guys. Please, 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 please do not forget this one. This is very, 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 very important, guys. This is very important. You need to know it always, guys. Does it make sense? They love to ask perpendicular lines. You just need to know that you must multiply the two gradients of the sides, then you get you can tell that it's perpendicular or not. If it doesn't give you -1, therefore it means it's not perpendicular. So if it gives you 1, not -1, if it gives you 1 only, therefore they are not perpendicular. If it gives you 2, it's not perpendicular. If it gives you -2, it's not perpendicular. It must give you -1. That's where you see that your lines are perpendicular, meaning that they are meeting at 90 degrees, right? Perfect. And always you use gradients to check whether your lines are perpendicular or not. Perfect. Now, let's move to the next question. It says now 3.5. Give a reason why a parallelogram ABCD is a rectangle. Who can tell me? 1 mark, guys. Why is a parallelogram ABC a rectangle? Basically, the other words, you must know the properties of a rectangle. So if you know the properties of a rectangle, you'll be able to give a reason why this is a parallelogram. So give a reason why parallelogram ABC is a rectangle. Who can tell me, guys? Going once, it's just 1 mark, guys. Going twice, going thrice. Guys. Yes, that's perfect. Opposite sides are equal. Very good. Tino and Luna. What else? What else? That's, yes, Kabza the Small. Perfect. What a funny name. Kabza the Small. Are you the celeb? Are you the real Kabza the Small? From Amapiano. Wow. Okay, guys. Wow. That's perfect. Okay. Okay, yes, guys. It's 90 degrees also. That's another one, right? All side, or Letabo says, all sides for all sides, 4 sides are 90 degrees. Yes, that's perfect. That's perfect, guys. Okay, cool, right? So all your answers are right, guys, but parallelogram is one interior angle at 90 degrees, right? So that's perfect, guys. All your answers are correct. So I'm glad, guys, you know your stuff, you know majority of your stuff. Perfect, right? Now, let's look at the let's look at 3.6. It says determine the equation of KL in the form of y is equals to mx plus c. Now, guys, this is a new thing. We haven't covered this, right? But you know it from grade 9. You know it from grade 9, an equation of a straight line. Does it make sense, guys? Can you see the importance of doing lots and lots of papers, guys? That's where you'll see how they ask questions, That's where you'll see how would they integrate most of the questions. So it says determine what? The equation of KL. Let's see, where is KL? This is KL. Can you see KL? This is KL. That's your KL, guys, right? Remember, in order for you to get a straight line equation, it's either you need to have 2 points or you need to have 1 point and a gradient, right? So far we have 1 point of which is K, but we don't have point L yet, the coordinates of L. So now, which means we're going to use what? We're going to use point K. And because they told us that KL and DA, they are parallel to each other, which means we can use the gradient, right, of dA. Does it make sense, boys and girls? I'm going to take you now. I just see, I'll take you through now. Okay, let me go here. Now, so now, because the gradient of AD, because they told us in the scenario that KL is parallel to AD, which means when lines are parallel, the gradient is also the same. So the gradient of AD is equals to the gradient of KL. Therefore, it becomes easy. Therefore, you can get what? The equation of KL, right? Because now you know that you've got 1 point and a gradient, right? Remember, in order for you to get an equation of a straight line, it's either you must have 2 points or you can have 1 point and a gradient, right? So in this case, yes, we've got a gradient and 1 point. So it makes it easier, right? So you must substitute everything, then you'll get your equation. Y is equals to half. The gradient was half x minus 2 quarter, right? That's your C, that's your point C, where it touches your y axis, right? I just need to show you here your negative 2 quarter. This is your negative 2 quarter. This is your point C, where it touches. Remember, guys, KL, where the line touches the y-axis, it's your point C. It's this C, right? Your M, remember, is what? Your M, it's the gradient, and the gradient, it's half, because we know that dA is parallel to KL, right? Therefore, which means we know the gradient of DL was half, so it's half x, right? Minus 2 quarter, because where it cuts on the y-axis is your point C. Perfect. You did this in grade 9, how to calculate the equation of a straight line. You did that, guys. So this should be easier for you. Okay, before I do the last one, I just need to look at the comments. Okay, perfect. Yes, you guys are following. Wow, you guys are so awesome. You guys are so awesome. That's perfect. Perfect. Okay, cool. Then 3.7, it says to you, write down with reasons. With reasons. Now they want reasons, right? They want reasons. So it says write down with reasons the coordinates of C, right? So now, as much as you're going to give the marker the coordinates of C, you must also give reasons, right? So, and it's for 3 marks. It's for 3 marks. And let's look at the coordinates of C, or let's look at point C. Can you see, guys, here? Point C. This is your point C, guys, right? In order for you to get point C, you can use what? You can use your straight line equation, because you're told that KL is parallel to CB. So here is KL is parallel to CB. So now point C, it's actually where it cuts at the, what you call, it cuts at your y-axis. So what you can do with this one, it's very easy, guys. There are so many ways of doing this one. It's either you can say, okay, in order for me to calculate point C, we know that AC is equals to BD. Therefore, is equals to 10 units, right? Therefore, 4 minus Y, C is equals to 10, right? Therefore, you know that your YC is actually your point C. So you can get it this way, or you can calculate it like this, right? You can calculate it like this, where you know that the gradient of BC is equals to the gradient of AD, right? Of which is half, right? Therefore, you work backwards to calculate point C, right? Because we know that where there is C, you know that where there is C, your X is 0, but your Y is something, because your point C is lying on your Y axis. Does it make sense, boys and girls? Let me look at the comments. Okay. Okay, that's perfect. Okay. Seems like everyone is following. Any questions, guys? Do you guys have any questions? We still have lots of time. We still have like 8 minutes. If you have any questions, you can ask during this 8 minutes, guys. I'm here to help you. Tracy, what is the XD that you're talking about? I see XD. Okay, Monica is asking, say, can you please go back to 3.3? Okay, let me go back to 3.3. Let's see what 3.3 was about. Okay. Oh, 3.3, it says calculate the gradient of AD. Okay, let's go back to 3.3, the gradient of AD. So remember the gradient of AD, here's your point A, here's your point D. So we're supposed to calculate what? The gradient of AD, and we said if it's an upward sloping, it means that you're going to have a positive gradient, right? So now if we look at 3.3 here, just need to take my cursor up. Yes. So 3.3, it was the gradient formula. You need to know the gradient formula. Gradient formula says y over changing x, meaning y1 minus y2 over x1 minus x2. Therefore, you substitute the y's of a and d, you substitute your x's of a and d. Therefore, 4 minus 2, you'll get 2, then 0 minus minus 4. Remember, a minus and a minus, it's a plus, guys, right? Therefore, you'll get 4. Then 2 over 4, it's half. That's how we got the gradient, right? I hope I've answered you, Monica. Okay, that's perfect. I can see you're acknowledging that. Okay. Okay, let me see. Can you go back? Okay, Monica. Okay. Okay. Sarah, did you also see 3.3? Okay, cool. Other questions? Okay, let me see. Okay. Okay, others wants the last question. Luna, sir, can you please explain the last question again? I'm going to do that. Okay, noted. Okay, cool. Okay, let me do the last question then. All right. The last question now, guys, let me go back to the actual question. The actual question, it says to you, write down with reasons the coordinates of C. So now, here's the coordinates of C, guys. Here is the coordinates of C. Remember, the coordinates of C, it's where C touches what? Your y-axis, right? Meaning, if you have a point in y-axis, we know that x is 0. So the coordinates of C, by default, it's going to be 0 is to something, because the point C is lying in your y-axis. Unlike when the point maybe is lying somewhere here, that's why you're going to have x is something, y is something. But now, because your point C is lying on your Cartesian plane, right? We call this cross a Cartesian plane, right? But we know that the vertical line is given by your y, and the horizontal line, you see here, the vertical line is given by y, and your horizontal line is given by x. Does it make sense? So now, even here, For example, if you have any point that is lying in your x-axis, which means y is 0. Does it make sense? Same applies with, sorry, guys, I don't know. Okay, yeah. Same applies with your point C. So your point C is lying on your y-axis, which means your x is 0. So point C, it's going to be 0 is to something, but we need to find that something in order for you to get your point C. But we already know one component of C, of the coordinates of C, that it's 0 is to something. Therefore, what they did here, there are two ways that they've showed you guys, right? There are two ways. Remember, you were told that BC, right? It's parallel to AD, meaning now BC and AD, if something is parallel, they share the same gradient. What is the reason? The side of a rectangle or the side of a parallelogram. This is the reason. So you are going to get a mark. No wonder there was a tick and R. So remember now, if you look here at the start, I told you guys that D, A, and CB, it's actually parallel to each other. And if lines are parallel, which means they've got the same gradient, but they'll never meet, but they share the same gradient. So we have calculated the gradient of AD, is the one that we calculated in 3.3, right? And it was half, right? Therefore, you must also do what? You know that the gradient of AD is the same as the gradient of BC because these are parallel to each other or to one another, right? Therefore, what do? You know that, okay, since that you use your gradient formula, so you're working backwards using your gradient formula. So you will try to substitute your coordinates, right? So you substitute the coordinates of B, you have them, and you also substitute the coordinates of C. But the coordinates of C, you know that this one is 0, right? It's 0, the x-axis is 0, no wonder there is 0, but you don't know what is the y one, right? So the coordinates of B, they were given as 4 is to -4. Therefore, you just substitute them here and you work backwards, and you know that this is equals to your half because you were told that BC is parallel to AD, right? Therefore, now you are solving for this unknown, right? This y. So you're using your gradient formula, but you're working backwards, right? So you're using this unknown, so you can just cross multiply here, guys. You can just cross multiply. When you cross multiply and do everything, you'll get YCS -6. Therefore, coordinates of C or point C, it's 0 is to -6. I hope I've answered your questions, guys. Okay, Tino is still asking, sir, can you please explain the straight line equation? Okay, Miss P says, and then says, sorry about another question here. What are we going to do after number patterns, if you don't mind asking? I'm only going to tell you when we're doing number patterns, guys. Just know in mind that next week we're doing number patterns. So while we're still busy with number patterns, I'll tell you again what you'll be doing. I hope that's perfect. Okay. All right. Then now, someone is asking for the straight line equation. Straight line equation, it was number what? Okay, let me check here. Straight line equation, it was number 3.6. It says determine the equation of KL in the form of y is equals to mx plus c. Remember, guys, in order for you to calculate a straight line equation, it's a two-way option. It's either you must have 2 points or you can have 1 point and a gradient. That's when you can calculate the equation of a straight line. In this case, KL, we have 1 point of which is K. But because we know that KL is parallel to DA, which means they share the same gradient, which means the gradient that you got here in 3.3, of which is half, is the same gradient as KL. So in order for you to calculate the equation of a straight line of KL here, you actually need point K and the gradient will be half. How did you get half? The gradient of dA is the same as the gradient of KL and is also the same the gradient of dB, because all these lines are parallel, guys. I hope it makes sense. Just know in mind that in order for you to calculate the straight line equation, you've got an option. It's either you are given 2 points or you have 1 point and a gradient. That's the only way you're going to calculate your equation of a straight line. Okay, guys, this is the end of our lesson. I hope to see you again next week. Have a nice weekend. Take a break, guys. But on Monday, we are starting again with number patterns. And I hope you guys will find them useful. I will be looking at different number patterns and stuff like that. Have a nice weekend, guys. Keep well, keep safe, wear your masks, wash your hands always, look after yourself, guys. The future is too bright. I believe in you so much, guys. Okay. Take care, guys.